Calculating square root by prime factorization. Prime factorization is a great tool to find square root of real numbers, especially when real numbers are perfect square. Let's try finding square root of 729 and 18,496. Square root of 729 will be denoted by the symbol 729 square root, and now we'll do small division of 729. Now 729 is written here, and on the top we can write first few prime numbers starting from 2, 3, 5, 7 and 11. And we take a look at the last digit of the number for which we want to calculate the square root. If that last number is an even number, we can start dividing by 2. If that is not even, we'll skip over 2 and we'll go to the next number, which is 3, and see if 3 will divide 729. Let's get started. 3. Read the table of 3 up to 7. Obviously 7 is not in the table of 3, so we can go only up to 6. 3 2 times 6, and 1 is the remainder which is carried over and makes 2 as 12. Read the table of 3 up to 12. That will be 4. 3 4 times is 12, and 3 3 times is 9. We continue to divide with the same prime number if the 243 is divisible by 3. So 3 and then 8 time 24, and 1 time is 3, and 3 again. 3 2 times is 6. 2 will be carried over, that will make it 21. 3 7 time is 21, and we do this divide by 3 again. That's 9 time, and 3 3 times, 3 1 time. So how many times 3 is a factor? 1 2 3 4 5 and 6. So we will write 729 equal to 3 times 3 times 3 times 3 times 3 times 3. So this is now 3 is multiplied, or 3 is a factor 6 times. Let's keep the square root and make the pairs. This is one pair, this is second pair, this is third pair. Now the rule is, if you have a pair inside the square root, you can take 1 out. So from this pair we're going to take 3 out, and from this pair we are going to take 3 out again, and from the third pair we are going to take the 3 out again. This will give us 3 times 3 times 3, so this is 9 times 3, and that is equal to 27, which means that 27 is square root of 729. Let's try the same thing with 18,496. 18,496, square root of 18,000, and we'll use the same technique again. And 18,496, and let's write few prime numbers like we did before: 2 3 5 7 11 and so on. In order to start the small division process, we're gonna take look at the last digit, which is 6, and it's even, so comfortably we can divide it by 2. So 2, and read the table of 2 up to 18. 2 9 times is 18, 2 2 times is 4, 2 4 times is 8, 1 is carried over, which will make 6 as 16, and 2 8 times is 16. We'll do the same division again because still the last number is even. So we will do 2 4 times would be 8, 1 carried over, and that will be 12, and 2 6 times is 12, 2 2 times is 4, and 2 4 times is lucky. We are, because still the last number is even. So we're going to do with 2 again. 2 2 times is 4, and 2 3 times is 6, 2 1 time, and 2 2 times. One more time with 2, and this time we have 2 1 time, 2 1 time, and 1 is carried over. 2 5 times, 1 is again carried over. 2 6 time. Still we're gonna keep 2 outside, so 2 5 times and 1 carried over, and 2 7 times is 14, 1 carried over, and 2 8 times, and 2 again. 2 2 times is 4, 1 is carried over, that will make it 17. 2 8 times is 16, and 1 is carried over. 2 9 times, 289. Now, as a student of mathematics, we should always know that first few numbers, what are their squares. I know for a fact that 2 for 289 is a complete square of 17 when 17 is a prime number. I know for sure that out of these numbers, 3 is not going to divide, 5 is not going to divide, 7 is not going to divide, 11 is not going to divide, even 13 is not going to divide, and the next prime number 17 is going to divide. As a student of mathematics, you should know the complete squares of at least up to 17, 18. Like, what is a complete square of 11? 121. What is complete square of 12? That's 144. What is for 15? That's 225. Similarly, we should know that 17 square is 289. So I am going to divide it 17. 17 times is 289, and then again 17 one time is this way we make pair. So we have 1 2 3 4 5 6. So 6 times 2 is a factor, and 2 times is 17 a factor. So let's write this down as 2 times 2 times 2 times 2 times 2 times 2. So this is 6 times 1 2 3 4 5 6, and then 17 times 17, and keep the square root, and let's make the pair. So it's 2, one pair, second pair, third pair, and this pair. Out of every pair you can take one common. So out of this pair, 1 2 will come out, and then from this pair 2 will come out, from this pair 2 will come out, from this pair 2 will come out. So 2 times 2 is 4, 4 times 2 is 8, 8 times 17, and now you can multiply 8 times 17. 8 7 times is 56. 5 is carried over, and 8 one time is 8, and then add 5, that will be 136. So you see that how easy it was to find square root of such a big number using technique called prime factorization. But numbers are not always going to be integers. They could appear in the form of fractions as well. Let's take a look on another number. For example, find square root of 2.56. Now 2.56, apparently we don't know what is square root of 2.56, but let's get started with this. And the first thing we can do, we are looking at a decimal point, and let's convert it into a fraction. Since the decimal is after 2 spaces on the right, so we can comfortably divide it with 100 and write 256. You have learned this technique before, and the square root will be over the entire fraction. Now 256, and as the property of square root, we have learned this property in the lesson 1, that if a over b square root is equal to square root of a over square root of b. So using that property, we are going to write square root of 256 separately and 100 square root separately. Now let's use small division or prime factorization to find square root of 256 separately and 100 separately. So 256, and we're going to write some prime numbers. It's some initial prime numbers 2, 3, 5, 7, 11, and so on. We know for a fact that 256 is a complete square of 16, but let's just use the prime factorization. 2 one time, 2 times is 4, 1 carried over, and this is 2, 8 times is 16, 2 again, 6 times, 4 times, and 232, 2, 16, 2, 8, and 2, 4, 2, 2, and 2, 1. How many times 2 is a factor? 1, 2, 3, 4, 5, 6, 7, 8. So this is a factor 8 times. Therefore, we're going to write 2 times 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 2. 1, 2, 3, 4, 5, 6, 7, 8. And 100 is a, obviously, if we can do the same thing, but we know that square root of 100 is 10. So if you want to do that by prime factorization, this is 2 times 50, 2 times 25, 5 times 5, 5 times 1, and here we have 2 times 2 times 5 times 5, and then let's making pairs. This is one pair, second pair, third pair, fourth pair, this one and this one. So what would be, from this pair 1, 2 will come, from the second pair 2 will come, from third pair 2 will come, and from fourth pair 2 will come. Okay, in the denominator 2 will come outside and 5 will come outside. Now if we divide, 2 times 2 is 4, 4 times 4 is 16, 16 over 10, and we can convert this back to decimal. That will give us 1.6. So square root of 2.56 is equal to 1.6. Similarly, try finding square root of 81 over 256. That question I leave it to you, and you will have similar questions in the exercise.